Hello everyone, I'm Frank, and welcome to Frank Puzzles. And this is today's easy level puzzle. But take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of smart people there. Today's puzzle is called Copious Coordinates, and it's by Flinty. And here are the rules. We have normal Sudoku rules applied, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. The 2 digits on an arrow give the coordinates of a particular target cell somewhere in the grid. The digit on the arrow's shaft indicates the target cell's row, and the digit on the arrowhead indicates the target cell's column. The sum of the 2 digits should be placed into the target cell, and no 2 arrows target the same cell. So, as an example, say we had a 3 here and a 6 here. On the shaft, it indicates the row number of the target cell, which would be 3. So this is row 3. On the arrowhead, it's the column of the target cell, which would mean column 6. So in 3, 6 here, if this was 3, 6, this would have to be a 9. Because the sum of 3 and 6 must be 9. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so what I find with these coordinate puzzles, the coordinated arrows puzzles, is it's good to know where every target cell could be. And then you can count how many you have. So this could be 2. So you could have 2 here, 3 here, and we're using colors that correspond to the digits. 4 here, 5 here, this is 6, 7, 8, and 9. So these are all the coordinated cells you can target. And since each arrow targets a different one, and there's a lot of arrows, that means we probably are going to have the maximum amount of coordinated arrows we can get. So how many are there? We can have 1, 2, 1, 3, 1, 4. So that's 3 there. 1, 2, 1, 3, 1, 4. We can have 3 5s. So 1, 2, and 3. So that's 6 in total. We can have 1, 2, 3 6s. So that's 9 in total. We can have 2 7s. That's 11 in total. We can have 1, 2, 3, 4, 5 8s. So that's 14 in total, right? 1 plus 1 plus 1, 3 plus 3 plus 3. No, wait, 9, 11, 16, sorry. We have 11 here previously. So it was 9 plus 2, which is 11, plus 5, 16. And we can have 1, 2, 3, 4, 5 9s. So that's 21. How many arrows do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So every single possible coordinated arrow is set. This is the maximum amount. We have to have a 1, 1 here. We have to have a... So that means one of these 2s is definitely guaranteed. So this is definitely guaranteed here. One of these three is guaranteed. One of these two is guaranteed. Both of these are guaranteed. So we're going to highlight the ones we know that are guaranteed. That are guaranteed cells specifically. It's this, these two, this one, the blue, the yellow there, yellow here, and this. So we are guaranteed these digits are coordinated, and then one out of the other choices, right? And so the reason, right, so how do you know this? This is 1 plus 1, it's 2. 1 and 2 add up to 3, 2 and 1 add up to 3. 1 and 3 add up to 4, 2 and 2 add up to 4, 3 and 1 add up to 4, and that, etc., etc. That's why I knew this was 2 value, 3's values, 4's values, 5's values, 6 values, etc. So we are guaranteed 1, 1, 3, 3, and 4, 4. The only possibilities for that are here, right? Where you have to be essentially not in the same row, not in the same column, and not in the same designated 9-cell region. So this must be a 1, 3, 4 triplet. This must be a 1, 3, 4 triplet. We don't know which one's which, though. Also, we know this. So this has to be 2. This has to be 3 plus 3, which is 6. This must be 8. We know this is a 5. This is 5. This is 8 and 8. And this is 9 and 9. So we also know 3 is guaranteed to be one of these two. 4 is guaranteed to be one of these 3. 5 is guaranteed to be one of those 2. 6 is guaranteed to be one of those 2. 6 is guaranteed to be one of those 2. 7 is guaranteed to be one of these 3. 8 is guaranteed to be one of those 2. 7 is guaranteed to be one of these 3. 8 is guaranteed to be one of those 2. 9 is guaranteed to be one of those 2. 9 is guaranteed to be one of those 2. And 9 is guaranteed to be one of those 2. You can never have 9 in an arrow. Because if 9 is in an arrow, how do you have a coordinated system? You can't, right? It's 9 plus 1 at minimum, which is 10, which is not a normal Sudoku, which is not a digit. So this cannot be 9, which means this has to be the 9, and has to be pointed to as a coordinated system. Okay. We have a lot of sets of the same set. So this is pointing to 5. So 5 also. So 5 as a row and 5 as a column. So this is 1, 2, 3, 4. It cannot be 2, cannot be 3. So this is 1 or 4 here. That means we have accounted for the 6 in box 4 and the 6 in box 2. Let's see. How many duplicates do we have? That's another thing. So these are pointing both ways, right? So that means you have one is a row, one's a column, and then the one's a column, one's a row. So they have to be like equivalents, right? So it would be like these two are equivalent. These two are equivalent, etc., etc. We have 1, 2, 3, 4, 5, 6 sets that are the same. 3 and 4 cannot do that. 5 can't do that. You can have a 1, 6, 1, 7. Oh, wait. No, you could have this 5. Okay. So 2 obviously doesn't work. 6 doesn't work. 8 here doesn't work. The 5s is 1. None of 3, 4, 5 here work. So 5s work here. 6s work there. That's 2. 7s work there, potentially. 8 works... Wait, so 5 here. 6, that's 2. 7 could be 3. 8, obviously this doesn't work, but you have 4 and 5. And 9, you could have 1 and 2. So that's 7. Okay, so we don't have a guarantee in these duplicates that every single thing is duplicated on the same row and column. Okay. Oh, we have an 8 here. This must be 1 and 8 then, right? Because if this is not 1 and 8, how does that work? It doesn't. It would add up to 10 at most. So this is 1. This is 9. So this must be pointed to. 1 and 8 already points to there, so this is satisfied. Yeah, let's change these to essentially, these are targeted, so let's make it a green circle around it. Okay. We have green circle. These are targeted. So this can no longer be 4 and 5, because if this is 4 and 5, that would be row 4, and 5 has to be a 9, which is impossible. So this is done. Actually, let's mark the green when we're actually targeting correctly. So this is 1 and 8, which targets that. So that satisfies that, and that's targeted there. This cannot be 4 and 5 again. Oh, it couldn't be 4, 5 anyways, right? Because then both of these would be 9, which is impossible. So this is 1. So it's 1 and 5. Row 1, column 5 is a 6. Row 5, column 1 is a 6 also. So those are both satisfied. Those satisfy these, essentially. This is 6 as a starting point. Could be 6, 1, 6, 2, 6, 3. Either of those work. Okay. This cannot be 7, though, because 6, 7 adds up to 13. This can't be 7, for the same reasoning. This can't be 1, because of the 1 in the column here. So this has to be 2 or 3. And this could be 1, 2, or 3 here. Let's see. Remaining digits in... Let's do row 1. We have 1, 3, 4, 7. This cannot be 4 and can't be 1. So this is 3 or 7. This can't be 3 or 1, so this is 4 or 7. This could be 1, 3, 4, or 7. 1, 3, 4, or 7. Okay. So we have these pointing. So these are essentially satisfied with these. 1 points to something else. So one of these has to be pointed at. It could be 1, 4. So one of these is 6 in with 1, 2, or 3. So we have either the 7, the 8, or the 9 accounted for doubly. In box 2 and 4. This has to be double. It cannot be 1, 8. But it doesn't have to be. We know there's a 6 in one of these 3 cells. Okay. Remaining digits in row 5. We have 2, 5, 6, 7, 8. It cannot have an 8 here because this would be both of 8 and 1, right? We can't have 2 and 7 either because that would... well, you could have 7 and 1. So this can never be 8. This can't be 8. 2, 5, 6, 7, 8. No 6 here. No 7 here. 2, 5, 6, 7, 8. Okay, no 5 here. This can't be 8. No 6 or 5. Okay, this 5 here eliminates 5 here. Where is the 5 in row 6 then? It has to be here. Oh, this 1 eliminates 1 here. So this can't be... this is 3, 4, 3, 4. That makes this 1. So this must be 1 and 1. So that's accounted for here. 1 cannot appear here or here in column in box 3 because of the 1s in the column. 1 can't appear here, so 1 is guaranteed to be one of these 2. Interesting. So it cannot be 1, 2. It can't be 1, 3. So this can't be 3. It could be 1, 4. It could be 1, 4. 1, 4, 1, 5 is already accounted for. 1, 6 is possible. And 1, 7 is possible. And 1, 8 is possible too. Well, no, 1, 8 is not possible. Because we have 1, 8 already here. This is 1 with... okay, so remaining digits in box 5. We have 2, 5, 6, and 7. 5 cannot be here. 6 can't be either of these. So 5 has to be one of these 2. Okay, 1, 2 adds up to 3. That's possible. 1, 6 adds up to 7, and 1, 7 adds up to 8. And those are all possible. Okay. We know 1 has to be one of these 2 here in row 5, because these can't be 1 in the rest of row 5. Remaining oh, this 2 eliminates 2 here. So this is 7, which means this can't be 7 anymore. Interesting. That eliminates 7 in the rest of the row. Remaining digits in column 1. We have 3, 4, and 9. So this is 3 or 9. Can't be 4 because one of these 2 is a 4. 3, 4, or 9, and this could be 3 or 4. So the column is 3 or 4 here. So column, it could be 1, 3. Or 1, 4, possibly. 1, 5 is... well, it can't have 1, 5. 2, 3 works. 3, 3 obviously does not. 2, 3, 4, though, does. 3 and 4 could work. Could work. 4 and 3 also could work. 5, so this is 5 up to 6 here, right? 6 and 3. Okay. One of these two was a 4, though. So that eliminates 4 in the rest of the box. So this cannot be 4 here. Okay. 2, 5, or 6. So that must add up to at 9 at most, so it's up to 7. No 6 here. No 1 here. No 5 here. No 1 because of the one of these must be 1 in column, or the 1 in the box. No 5 here because one of these must be 5, and 6 cannot be here. So how, this cannot be 2, 2, but it could be something like, okay, so it cannot be 2, 3. Can it be 5, 2? 2, 5, and 5, 2 are not possible. 6, 2. 6, 2 does work. Okay. Remaining digits. Okay, so do we have enough 9s? So 9 has to be one of these two here in row 2. 9 is one of those two. So we have 2 6s already. There could be a third 6. So we don't have the 5s yet. So 1, 4, and 4, 1 definitely have to appear somewhere. This can't be 1. Okay. Where is 8 in box 6? Cannot be here because of 8 in the row. Can't be here because 8 in the box. Can't be here because of the arrow. So 8 has to be one of these two. Where is the 8 in box 9? It has to be one of these two. Obviously, oh, this cannot be 8 here because there would be 8 and 1 guaranteed, but we already have a 1 in the box. So 8 has to be here in box 9. That means where is the 8 in box 8? Cannot be here, cannot be here. It's one of these two. But this could be 8 and 1 here, right? Okay, let's see. What else do we have? Oh, obviously this can't be 6 anymore. This can't be 6 anymore. One of these three is a 6. Remaining digits of row 7, maybe? 2, 5, 6, 7, 9. Okay. 9 cannot be here, cannot be here. No 5 here, no 6 here. No 6 here. And no restrictions there. That's not that helpful. Okay. Remaining digits of column 7? No, column 4. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 6, 7. Okay. And this can't be 7. It can't be 6 here. This can't be 1 because of 1 in the row. Okay. what is this combination? Obviously no 9. 2, 3, 4, 5, 6, 7. It's a one-way arrow. Okay. Huh. Well, 14, 17, 18, 19, 20, 21. What else do we have? We really need to figure out these arrows, I guess. Oh, wait. We have 1 and 8 here. That means this cannot be the double arrows. Right, because if you have 1, 8, if 8 and 1 were one of the double arrows, the problem is... Yeah, so then we know where all the double arrows have to be. It's one of them's 5. We already have the 6 accounted for here. One of them must be 7. So this must be 7 and 7 here, then. Which means this can't be 7 here. One of them, we have 2 sets of 8. So 1, 5, 1, 6 for the double arrows. 1, 7 for the double arrows. 2 8s. 1, 8 here and 1, 8 here. And then 1, 9. Because this cannot be a double arrow 9 anymore. Because we have a 1, 8 here. So, that means all of these are accounted for. So it's 7 and 7 as a double arrow. We don't have it accounted for. So we need a 1-4 pair as a double arrow. Well, the only 1-4 pair as a double arrow can only be here. So this must be 4. So this must be 4, which makes this 1. Oh, that means 4 has to be 2 and 2. That's not going to work. Ooh, that's bad. Wait, why can't this be 4? This could be 4. Yeah, this can't be 2 and 2 anywhere. Because you have to have them be in the same row and column. So that's why this can't be 4, so this must be 4 here. So this is 4, which means this can't be 4 or 7. This is 1. This can't be 7, that's 3, which makes this 9. So no 9 here. Which means we cannot have 8 anywhere on an arrow anymore, because it can't be 8 and 1 here. So this must be 8 here, which means this can't be 8 here. This is 1 and 4. I don't know how I completely forgot about having a 4 there. So this is 1 and 4, which eliminates 1 and 4 here. So this is satisfied. That points to here and here. 1 and 8 is done. It points to that 9. 5 and 1 is done. 1 and 1 is done. So, we need a lot more 1s. We need 1, 3. 1, 2. That's going to be problematic. One 6. I guess this could be 6 1. Right, we need all the 1s almost to be like... This can't be 1. So this could be 6 1. This could be 6 1. This 7 eliminates 7 here. This is 2 6 as a pair in box 5, which eliminates 2 and 6 in the rest of the box. So this can't be 2. This is 5. This can't be 2 or 5. It's 7. which eliminates 7 here. We need 1, 2, and 1, 3 also. So 5 can be 2 and 3. So we got the 1, 4. We have the 1, 5. We don't have 1, 6 yet. We need 2, 6, or 3, 5. And so that's one of these. Or this. And we need 3, 6. Which could be here. Okay, this can't be 7. Well, you couldn't have 2, 7. Anyways. So this is 2 or 3, which means it cannot be 2 here then, because that would be 2 and 3, which means both of these would have to be 5, which is not 2. True. This is 3, 4 as a pair, which eliminates 3 and 4 in the rest of the box. So this is 4 here, which eliminates 4 in the rest of this column. And this can't be 4, this can't be 4, so 4 has to be here. Which means 4 has to be one of these two here. The remaining digits in box 4 are 1, 2, 3, and 8. 1, 2, 3, and 8. This can't be 1 or 8, it's 2 or 3. That means 7 has to be one of these 3 here. This can't be remaining digits in column 6. We have 1, 2, and 6 here. Obviously 6 can't be here. This is 1 or 2. 1, 2, and 6 here. So 1 could point to 2 or 3 or 6. Oh, this is a double. So you can't have 2 be a double. Or you could have 2 be a double. Okay, so 1, this cannot, okay. So as a double, you have 1 and 6. That's it for 1. Oh, 1 and 7. No, 1 and 6 and 1 and 7. 2 cannot be 3, 2, 3, 4, 5, or 6. So we know this has to be 8 here. So it's 3 and 5. This is 8, which makes this 8. To be the corresponding, which makes this 2, which makes this 3, which makes that 1. Okay, that's good. So this is 6 and 1. That points to the 7. So the 7s are pointed to. We need 3 and 5. So this can't be 1 and 7 anymore. It would be 1 and 6. Oh, we can't have 1 and 6. We can't have 1 and 5. We can't have 1 and 4. Wait, why can't this be... Oh. Why can't this be 1 and 7? This could be 1 and 7. Oh, okay. I made some bad assumptions. So this actually could be 4 or 7. Ugh. Okay, so we don't have these accounted. I'm feeling like I should reset this because I messed this up. Yeah, let's just go back from the beginning and then... Okay. Okay, what does everything? This has to be 2. This has to be 6. You have to have 8 here, 5, and 5. 8 here. 8 here, 9 here, and 9 here. So this must be 1 and 8. So that points to there, right? 1 row. 1 is in the shaft, which is the row. 8. So that's 9. So this is 9. So this is fulfilled. Again, cannot be. This cannot be 3. 3 is guaranteed to be here. It's 1 or 4. It can't be 2 because of 2 in the box. So this is 1 or 4, but you can't have 4 and 5 be both of there. So this must be 1 and 5. Which means, oops, this is pointed at and this is pointed at. So that's 6 and 6. So that's done. This is 1, 2, or 3. This has to be 2 or 3. So again, one of these is 3 here. One of these two, this can't be 4 because we have already 1, 2, 3, and 4 pointed to. This is 3, 4 as a pair. Therefore, this is 3, 4 as a pair. So this is 1, and this is 1. We can't have 2 and 2 pointed to, so this must be a 4 here. So these are all pointed to 2, 6, and 8. And these are the ones that are pointing to it. Remaining digits is, so this is 4, one of these is 5. One of these is 7 here. Again, one of these is 8. One of these is 8. And this has to be 9 here. And one of these is 9. But we have, again, for the double arrows, we can't have 8 and 1. So this can't be 8 here, which means this is 8 here. Which means the corresponding double arrow has to be satisfied because we already have them accounted for if you include this one. This one can't be a double arrow anymore, so we only have 6 possible double arrows, and therefore one of them is here. Okay. This cannot be 1 with 3 or 4. Can't be 5, so this is 2, 6, or 7 here. Because you can't have 8 and 9, obviously. So the double arrows, we need 1, 1, 4. Okay, so remaining digits in row 1. We have 1, 3, 7. This can't be 1, though. This is 1, 3, 7, and this is 1, 3, or 7. 7 can never be on a double arrow, right? If it were, 1 can't be here, 1 can't be here, 1 can't be here, so we're guaranteed a 1 here as a double arrow. It could be 1, 4. You could have 1, 7. So 7 could be here. Never mind. You could have 3, 5. So those are all satisfied. Oh, we have a 3, 4 pair, which eliminates 3 here. Remaining digits of box 5, 2, 5, 6, 7. This can't be 5, no 6 here. So 5 has to be one of these two. Huh. Remaining digits of row 6. 2, 5, 6, 7, 8. Okay, and this cell sees all of 2, 5, 6, and 8, so this is a 7. So this must correspond to a 7 here, which makes this 3. This is 1. Okay. So 7 can no longer be these. So these are the arrows, which means 6, 1 has to be one of them. 6 can be any of these 3. Because 6 is here, 6 is here, so 6 has to be one of these 3. 8 is one of these 2. 8, again, you could have 8 and 1, but the problem is we already have a 1 in the box. So 8 can't be here. 8 can't be on the arrow, 8 has to be here. Means this can't be 7 or 8. No 7. This is 2, 5, or 6. This can't be 5 or 6. This is 2. Which means this is 6. This is then 5. So no 6 here. No 7 here. This is then 1 and 2. This is 5. This is 7. No 2 here. So we have 1 and 2 pointing at 3, which is valid. This is 5 as a doublet. Cannot be 4, 5. Can't be 2, 5. Can't be 1, 5. We already have that pointed to. So this must be 3 and 5. So this is 3, which forces this to be 1 here. 6 and 1 is now pointing to both 7s. So 7 and 7. 5 and 3 is pointing to both 8s. 5 and 3. And 5 and 3. That leaves a 2, 4 pair in rest of row 5. 1 could be 1, 4, or 1 and 7. This cannot be 6. So we have 4 and 7 here. Where is 8 in column 9? Can't be here because of 8 in the boxes. Can't be here because of 8 in the rows. Can't be here because 8 and 1 can only be the coordinated arrow, and we have a 1 here. So this must be 8 here, which eliminates 8 here. That leaves this as 8. We should have 8 8s. We have 8 8s, so we know where the last 8 has to be. It has to be here. This can't be 3. We are missing 3 and 4 in column 9. So this cannot be 9 here. Oh, wait. That's the reason why this can't be... This can't have an 8 here. Well, we couldn't have an 8 here anyways because of that 8. Yeah. So this becomes 9. This is a 3, 4 pair here. Remaining digits in column 6 are 1 and 6. This cannot be a 6 here. So this must be 1 because of the 6 in the box. So this is 1. This is 6. 1 and 4 and 7 again are the remaining double pairs that we can have, right? That leaves this as a 6. Remaining digits in box 4 are 3 and 4. This can't be 4 because of 4 in the column, so that's 3. This is 4. Remaining digits in row 4 are 6, 7, and 9. This can't be 6 or 9 because 6 or 9 in the column, so this is 7. And we have 6 or 9 here, 6 or 9 here. Okay. That means this must be a 9 here because there's no other place for that. So we have to have 7 and 2. So this is 4 and 7. Remaining digits in row 2 are 2, 3, and 5. 5 cannot be here. So this must be 2 and 3, which forces this to be 5. That leaves this as a 7 here. Remaining digit in box 2 is a 4. Remaining digits in row 3 are 2, 3, and 5. This can't be 3 or 5 because 3 or 5 in the column, so this is 2, which leaves this as a 3, 5 pair. Remaining digits in column 2. 1, 2, 3, 4. We have 5 and 6. This can't be 6 because of 6 in the row, so this is 5. That's 6. 5 has to point to 4. So it's 5 and 4, which makes that 3. So this is done. It's pointing to the 9 here. Wait. We don't have the 6 and 3 double it. Oh, you can't have 6 and 2. Right, so this has to be 6 and 3. Okay, so that's 6 and 3. This is 2. They point to the 9s. And we have a 7 and 2 that we need to point to. So what are the ones we're still missing that we don't have? These we don't have. 4. The 5 is counted for now. And the 8 is counted for now, actually. So 8s are 1 and 7. 5s are 1 and 4. So we're still missing this one and this one. Right? We have 1 and 1 pointing there. 1 and 2 pointing there. 1, 4 as a pair with one of these two. 1, 7 as a pair pointing to the 8s. 1, 5 here pointing to the 6s. 1, 6 pointing to the 7s. One of these is 1, 7, so that's done. 1 and 8 pointing to there. 3, 3, 4, 4, and 3, 5 as pointing double pairing. So that's all done. So then one of these, we're missing 3 arrows. Where's the last one? It has, no, I already did that. 2, 3, 4, 5. So one of them is 1 and 3. One of them's 2 and 3, and we have 7 and 2. Well, the only one that shares a column is 3. So this must be 3, which makes this 1 and 2. This obviously can't be 1 because of one of the columns, so this is 2, this is 1, and that leaves this as 7, 2. The point to there. So 1, 3, and 2, 3 both point to these cells. And 7, 2, row 7, column 2, points to the 9. So now we are all done. And now we just do normal Sudoku. 3 eliminates 3 here, so this is 4, which makes this 3, which makes this 4, which makes that 3. 3 eliminates 3 here, so it's 5 and 3. 7 eliminates 7 here, so it's 4, which makes that 7. We have 6 and... 2 here eliminates 2 here, so it's 4 and 2. We have 2 and 7 remaining here. This can't be 2 because of 2 in the row. So this is 7, that's 2. Remaining digits in column 4 are 1 and 7. 7 can't be here, so it's 1 and 7. Remaining digits in column 5 are 5 and 9. This can't be 5 because of... Sorry, it can't be 9 because of 9 in the row. So this is 5, that's 9. That leaves this as a 6, which means that can't be 6, that's 9, that's 6. That leaves this as 4 and 9, which makes that 4, that 9, and that's a 5. Apologies for that. I don't know, I got a little bit discombobulated in the middle here. Oh yeah, so these are done, obviously. Yeah, okay, yeah, that was nice. I've done a lot of coordinated puzzles before, so the logic here was rather simple for me. I just messed up a little bit on the execution here, so sometimes that happens. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.